Here we are going to discuss how to conduct a chi-square test for independence. So let's start with the hypothesis for chi-square test. The null will always be saying that in the population of the two categorical variables, there is independency, so that there is no association between the two categorical variables. And hypothesis, the alternative hypothesis will be saying that there is an association, okay, that they are dependent on each other. So a quick search reveals that you can use a chi-square test of independence, also known as a chi-square test of association, or better said, no association, to determine whether two categorical variables are related. So if two variables are related, the probability of one variable having a certain value is dependent on the value of the other variable. So it's whether or not if there is an association between two qualitative variables. That's when you use the chi-square test for independence or no association. So for our example or scenario, we can revisit the two-way ANOVA we did in the previous video, and we can use the contingency table. Okay. So here now, the ANOVA is more extensive than the chi-square, because what it does, apart from determining whether or not there's a difference in the mean, it also determines if there's an association. So it's like an ANOVA with a chi-square in it. Okay, so we can use this table and because a contingency table agreement to prove whether or not there's a difference, whether or not there's an association between drugs and disease. So the two categorical variables here will be disease and drugs. So the research topic here about the population along that line, disease and drugs. So the research question pertaining to the population, is there an association between disease and drugs in the population? And the hypothesis, the claim, a response to the research question without empirical data, is claiming that there is an association between disease and drugs in the population. So this hypothesis, this claim has to be tested. So therefore now it is all about to determine if there is an association between disease and drugs in the population. Now to do this now, we need a sample. So here we are using the sample that we used in the two-way ANOVA to determine whether or not there is an association between disease and drugs. So basically you have to input this data in the online calculator. But before we do so, let's go through our steps. So step number one is to state the null hypothesis. The null hypothesis will always be saying that there is no association, whereas the alternative hypothesis, which is the claim in this case, will be saying that there is an association. So we can just simply copy this and paste this, because basically for the chi-square test, the hypothesis will be in words. So the alternative is saying that there is an association, whereas the null is saying there is no association. Step number one. Step number two is to input the data in an appropriate calculator. So let's do that for a chi-square test for no association, or chi-square test for independence. Again, we are going to use Statistics Kingdom, chi-square test for calculator. And it's also called a goodness of fit. No, it's a chi-square test for independence. Okay. But there are different types of chi-squares. You have the goodness of fit, you have the McNamara, and you have the McNamara, and you have the independence or association. So that's what we want to use. Our significance level is 0.05. So what we need to do is to input our data. We need one more column and two more rows. because we have 4 different types of drugs and 3 different types of disease. So now we have inputted our data in the calculator is to identify the p-value, which is also called a judge or the jury because a decision has to be made. And let's calculate and scroll down a bit to get the p-value. As you can see, this type of calculator is not so user-friendly, does not give the p-value directly. It's recommended to use a different calculator than the statistics kingdom for chi-square test for independence in that regard. I'm not seeing the p-value directly. So if you are looking for the p-value, the statistics kingdom does not give it to you directly for the chi-square test for independence. Or it could be that I'm not seeing it. Okay, so let's try a different calculator. So let's try social science statistics chi-square test calculator. And here's the contingency theory. So please enter group or categories. So this is A, B, C, and D, and drop 1, 2, 3, and 4. We have labeled the rows and the columns. Next, input the data. Please enter your data. So here we are to enter the frequencies. How many of them? So for example, 4 patients had drug 1 and this is A and so forth and so forth. Next, our significance level, we leave it at 0.05. And calculate chi-square. So we have a test statistic of 1.5163 and the p-value is 0.95847. So that's pretty high. So therefore, remember the decision criteria says that if the p-value is less than the significance level of 0.05, we reject the null statement. But if the p-value is greater than the significance level, we do not reject the null statement. So here now, our p-value is 0.95847, which is much greater than the significance level of 0.05. So we do not reject the null hypothesis. So we must conclude with the null hypothesis because we did not reject it. All right? Because if the null hypothesis is rejected, then the alternative is the conclusion. But if the null hypothesis is not rejected, it is the conclusion. So in conclusion, we have to see that there is no association between the drugs and disease because we have to conclude with the null because we did not reject the null. And why? Because the p-value is greater than the significance level. So the test has proven that there is no association between drug and disease.